If I asked you what state of matter light is, what would you say? No, really, physically speaking, what is light? Light is not a solid, it's not a liquid, and it's not a gas. It's not even plasma. In fact, it isn't even matter at all. And yet it still shapes our entire universe around us. It gives plants life. It's the fastest thing in the entire universe. It even lets us see. But light isn't just some simple beam of energy. There's something far stranger going on here. Something that pushes us into the world of quantum mechanics and radiation. First, we have to start with the basics. Everything around us is made up of matter. Light is not matter because matter requires mass and light has no mass. Matter takes up physical space. If you cram matter into a box, the box will become full. But light doesn't work that same way. Light is energy, not matter. So you can technically cram an infinite amount of light into a box without the box ever filling up. And that is why light is the fastest thing in the entire universe. It has no mass, so it can travel at the speed limit of the universe. And yet, even though it isn't matter, we can still interact with it. We still see light travel and refract through water. We can still see light bend through massive objects in space. Light is still there, it's just not there in the same tangible way that matter is. But now, onto what light is really made of. Light is carried by photons. Photons are massless particles, meaning they travel at the speed of light. Photons only carry energy and momentum. And the really weird part about light, or photons, is that they behave as both particles and waves. This is called particle-wave duality, and you're gonna have to bear with me a little as I go into some quantum mechanics. Imagine a pitch black dark room with only one small square window. If light only behaved as particles, then this light from this window would cast a perfect square on the ground. Particles travel in straight lines. So if it traveled through this window, it wouldn't branch out or move anywhere else. It would be a perfect square. But that's not what happens. If you really shine light through this window, it wouldn't just cast a light square onto the ground. It would brighten up most of the room, and light would even reach some of the corners of the room. This could never happen if photons were only particles, meaning they only traveled in straight lines. The reason that most of this room glows even outside of the windows area is because light is also a wave, meaning it ripples through just like a wave would. The light travels across the room rippling like a wave, and yet when it lands on something, it still lands sort of like a particle would in a straight line. And this is the strange dual nature of light. No matter where it's traveling, it's always spreading out across its particle waves, reaching areas it normally shouldn't reach. When I say that photons act like a particle wave, they literally act like ripples in water. Imagine that. But light, the stuff we see with our own eyeballs, is only a sliver in a much larger spectrum called the electromagnetic spectrum. This includes radio waves, microwaves, infrared, visible light, which is the stuff we see, ultraviolet, X-rays, and gamma rays. And technically, all of these are a form of light. The visible light that we see all around us is just a small portion of the actual light that our eyeballs can detect. And energy across this spectrum changes. Stuff lower on the spectrum, like radio waves and microwaves, have a lower energy, meaning they can't harm us. The reason why sunlight is very warm is because the sun produces a lot of infrared waves, which can't really harm us like radiation. As you move further up the spectrum, the particles have more energy and become more chaotic. Ultraviolet radiation is the stuff that the sun produces that causes sunburns. And technically speaking, these sunburns are kind of like miniature radiation burns, which is why if you are exposed to a lot of ultraviolet radiation, you can get skin cancer later on. When you go even further up the spectrum into X-rays and gamma rays, this reaches ionizing radiation, which is capable of knocking the electrons out of atoms, which literally damages the atoms, which is where you get radiation damage. But after all of this, we've concluded that light is not matter. It's not something that you can touch or hold with your hands. It's a wave-particle duality that acts as both a particle traveling in a straight line and also as a wave rippling out across area. And also that light is just a small part of a larger spectrum of radiation and light. But through and through, light is the ripple energy that gives plants life. That's the fastest thing in the entire universe. It lets us see and it lets us live. Without this light, our entire universe would be dark and there'd be simply no life. So yeah, light may not be matter, but it sure does shape everything that does. If you enjoyed this video, please like and comment your thoughts down below and subscribe for more. And until next time, peace.